Hello, everyone. My name is Tom Yamashita, and I'm presenting on some work from my master's on temporal partitioning as a means for wildlife to persist around the road in South Texas. So, to start, wildlife perceive humans as threats, which affects how they use the landscape. However, human activity varies greatly at fine spatial and temporal scales, so wildlife may be able to adjust their behaviors in response to this variation. Typically, around roads, human activity is often localized to the road itself and only during the day, with less activity in the surrounding habitat and at night. Therefore, wildlife living in the road effect zone may be able to take advantage of this dynamic nature of human activity and use road areas at times when activity is low. It's especially important for looking at how wildlife crossings could be used by wildlife in high human development areas. So the objectives for this study were to compare dial activity of mammals along roads to the surrounding habitat, and then to assess how the number of events at camera trap sites were related to distance from the road, canopy cover, maximum temperature, and lunar fraction. To do this, we set up 2 camera trap arrays between December of 2018 and October of 2019 along State Highway 100 in Cameron County, Texas. The first array was located at wildlife crossings and wildlife guards along the highway. This was our roadside array. And then our second array was set up in the surrounding habitat within 150 meters of SH100 using a stratified random sampling design. This was our habitat array. So to set up this array, we stratified our sites by side of the highway and canopy cover. We initially defined canopy cover using a classified vegetation map, and then when we went to each site, we measured the canopy cover. We split these sites into 3 different classes: dense, mixed, and open. So we conducted our analyses on humans and then wildlife with greater than 90 independent events on both arrays. Dial activity was computed for each array and then compared using a wall test. We then assessed the relationship between the number of daily events and canopy cover array, daily maximum temperature, lunar fraction, and interactions between canopy cover and the others, and between array and the others, using a generalized linear model with a negative binomial distribution. We used AIC model selection to identify the top models, and then model averaging to estimate the beta coefficients. So we found that human activity varied on the 2 arrays, with greater activity occurring throughout more of the day on the roadside array. We were able to conduct our comparisons on 11 different species. These were bobcat, coyote, jackrabbit, cottontail, bobwhite, armadillo, striped skunk, opossum, javelina, nilgai, and white-tailed deer. So we found that most species showed greater nighttime activity and lower daytime activity on the roadside array. And most of this nighttime activity occurred when human activity was lowest. And now in our regression results, we found that most species seem to prefer greater canopy cover. However, only some species avoided the roads, while some were even more likely or more often seen on the roadside array. Finally, we found that canopy cover tended to be less significant on the roadside array than the habitat array. We saw large differences in human activity in showing the highly localized nature of human activity along roads. However, most species did not actually avoid the roads, and some were even found more often on the roads. That indicates that wildlife may not be using spatial partitioning to avoid humans in the road effect zone. They may in fact be using temporal partitioning, especially because most of the peak activity for wildlife occurred during periods when human activity was lowest on the roadside array. Additionally, it's interesting that canopy cover was important. However, on the roadside array, at wildlife crossings and wildlife guards, it becomes less significant than more natural habitat, indicating that human disturbance may in fact be more influential than cover at determining when an animal or whether or not animals will use a particular site. So with that, I'd like to thank the Texas Department of Transportation for funding this work and Fish and Wildlife for providing land access. And I'll take any questions you have. Thank you.